this lesson we're going to talk about the product rule. Okay. The product rule is basically a method we're going to use to find the derivative of products of functions. And so here, if I'm given two functions f and g, and we're going to assume that they are both differentiable, meaning their derivative and their limits exist, such that f, capital F, is little f times g, then the derivative can be found using our limit definition. Okay? And it says the limit as h goes to 0 of our function at x plus h minus our function at x divided by h. Okay? So here, just like before, we use algebraic techniques to manipulate this. We'll start with our original function, and then we're going to do this little trick. We're going to add and subtract the same term. I'm going to look at f times g of x plus h, and I'm going to add it and subtract it, so I haven't changed my function. And then what we can see is if I group these terms together, so these first two terms and these last two terms, then I can see I can factor out a g of x plus h, and I've got f of x plus h minus f of x. And in the second grouping, I can pull out an f of x, and I get g of x plus h minus g of x. And when I look at these two separations a little bit closer, I can see that the second part of this, the f of x plus h minus f of x over h, the limit of that as h goes to 0 is just going to be f prime. The limit as h goes to 0 of g of x plus h just goes to g of x. Limit as h goes to 0 of f of x, just f of x. And again, the last piece, if I look at the limit as h goes to 0 of g of x plus h minus g of x, this goes to g prime. Okay. So here, we actually get our product rule, which says if I am looking at the derivative of an f times g, this is going to be f prime times g plus f times g prime. Okay, this is one of the rules that you're going to be tested on throughout the course and in the final exam. Okay. So let's look at two examples. In this first example, I've got a function x squared plus 3x and another function 4x plus 5, and I want to find the derivative of their product. Okay? So this product rule tells me I'm going to take the derivative of the first term multiplied by the second plus the first times the derivative of the second. And we can use the prime notation or the Leibniz notation to denote this. So in this case, I'm using the prime notation. Okay. So now we can actually calculate the derivatives where needed. So derivative of x squared plus 3x, I can use my basic properties. That's going to be a 2x plus 3 times the 4x plus 5. Here the x squared plus 3x stays the same, and I'm going to multiply by the derivative of 4x plus 5. In some of your problems, you're going to be asked just to find the derivative, and you can leave it here. In other problems, you're going to be asked to simplify this. And so in simplifying, we're going to want to multiply out. So we'll have an 8x squared plus a 12x plus a 10x plus 15. And over here, 4x squared plus a 12x. Okay. And once we multiply out, we'll combine like terms. So f prime of x looks like 12x squared. We'll get a 24, 34x plus 15. Okay. In this next example, we'll use the Leibniz notation. Okay, so again, I've got two functions, x to the 2/3 plus 3 and x to the negative 1/3 plus 5x, and I want to find the derivative. Okay. as I said, we'll use the Leibniz notation. So my derivative of f with respect to x is going to look like, again, the derivative of the first term times the second plus the first times the derivative of the second. Okay. From here, just like before, I can now apply my derivatives. So in the first case, my derivative is going to look like 2/3 x to the negative 1/3 times the second term, x to the negative 1/3 plus 5x. Here, the first term stays the same. And derivative of the second term. Again, we can leave it here if we're just asked to find the derivative, but we may also be asked to simplify. Okay. With the negative exponents in here, obviously it's going to be a little bit more challenging to simplify this, but again, we would start by distributing. So here we can see this is going to be 2/3 x to the negative 2/3 plus a 10/3 x to the positive 2/3. So just distributing that first set. And then here we'll FOIL out. So multiplying here looks like a negative 1/3 x to the negative 2/3 minus an x to the negative 4/3 plus 5x to the 2/3 and a 15. Again, combining like terms, we'll go most positive powers first. So we'll have 15, and a 10/3, and a 5. So that's a 25/3 x to the 2/3. Then the negative 2/3 terms, we'll have 2/3 of them minus a third, so plus 1/3 x to the negative 2/3. And lastly, our minus x to the negative 4/3. This is our our derivative of f with respect to x. Okay. In this case, you don't have to worry about rewriting the negative exponents, only because our problem started with some negative exponents in there. So in this case, to simplify it down, I just needed to get back to the same types of numbers that I looked at when I originally started the problem. So let's look at an example. An example of the expanded property of the product rule. In this case, we've got f of x equaling x plus 2, x plus 3 times x minus 4. So our derivative, f prime, says we're going to take the derivative of the first term times the other two plus the first times the derivative of the second times the third plus the first two times the derivative of the last term. Okay. Now here the functions are really nice, but this is going to be the same properties that we'll use for any products. Okay. Taking our derivatives, in the first case we can see the derivative is just 1. Likewise, in the second term, the derivative of the x plus 3 is just 1. And in the last case, again, our derivative for x minus 4 is just 1. Again, once we've taken the derivatives, we'll multiply out. to combine like terms. That should be 2. So there would be our f prime of x, again using the expanded product rule.